This next chapter is chapter 33, and it concerns the solution in a vacuum of electromagnetic waves. After Maxwell came up with his four equations that governed the electric field, basically those equations had the form of electric and magnetic fields on one side of the equation and charges and currents on the other side of the equations, along with changes with respect to time of the magnetic field for the electric and changes with respect to time of the electric field generating the magnetic. So there were two things that generated the electric: charges and changes in the magnetic field. For the magnetic, currents and changes in the electric field. Well, he looked at how to solve these equations, and they're incredibly difficult to solve. And he said, maybe I can solve these in a vacuum. In a vacuum, by a vacuum, he means there are no charges and no currents. And so he proposed to look at a vacuum and say, can I solve Maxwell's equations in a vacuum? And basically, when he was trying to do that, if I can bring back our previous sheet here for a moment. What he's going to be doing is he's going to be making this term zero, so it looks just like the Gauss's law of electricity. It will look like Gauss's law of magnetism because there are no charges, so this is zero. And he's going to make the currents zero. So these two laws look very much alike too. Changing magnetic field gives rise to an electric, changing electric gives rise to a magnetic. And he had the idea that perhaps, just maybe, electric and magnetic fields could exist in a vacuum without any charges and currents that generate them. How would that be possible? It would be possible if you had a situation where your magnetic field was oscillating or changing, and it generated an electric, and the electric field was changing in such a way that it generated a magnetic field, and the two created each other, or made a solution possible that was self-consistent. And so he pursued that, and what he was able to show was the following. This is an overview of his discovery in this chapter, this module 33.1. He was able to show that there is a solution, and it can exist with any frequency, and any amplitude. And if it will consist of oscillations like this for the electric field and this for the magnetic field, perpendicular, so that this is a right angle between the two, that the electric field must be equal to the velocity of light times the magnetic, and that the speed of light, or speed of propagation, must be 1 over the square root of epsilon naught mu naught. These are the conditions must exist. And if those conditions are met, if the electric field is that times the magnetic field, factor of C, and if C is 1 over the square root of epsilon naught mu naught, then any frequency of oscillation for the electric field with a perpendicular, I should mention that, the perpendicular magnetic field, and at any amplitude, can exist in empty space and solve the equations. And those equations, those waves, electromagnetic waves, will carry both energy and momentum, and they're transverse. That means the wave moves this way, whereas the electric field moves this way, and the magnetic field will be perpendicular to it in this other direction. The E direction is often used to indicate the direction of polarization, and it is only because it's a transverse wave that we have a polarized wave for light. Well, basically, this is a discovery of incredible magnitude. Basically, this tells us that electromagnetic radiation can exist in space, and therefore the electric and the magnetic fields are real. They exist independent of whether there are charges. Of course, I need to create them with some kind of charges and currents. But once they're created, I can take those and neutralize them and get rid of them, and I'll have a propagating field. And this propagating electromagnetic wave includes visible light, gamma rays, X-rays, microwave, radio waves, and the whole phenomena of the electromagnetic spectrum. And in the visible light, of course, all the different colors. They're just different frequencies, and the brightness is normally associated with the amplitudes. Now, the polarization can also be circular, with either right or left-handed polarization, and that actually corresponds to the fact that these will later be shown to consist of photons, or gamma, or what we use the small letter gamma to represent a photon. And later we'll understand in our quantum theory work that this electromagnetic radiation is just a general description of the motion of many, many photons, which carry the equivalent of the electric and the magnetic field. So Maxwell's discovery was phenomenal. He looked at the equations that he had made consistent. He then said, can a changing magnetic field give rise to an electric? Can a changing electric give rise to a magnetic in a self-consistent way? Can I solve those equations? And in the next section, we'll see what that solution looks like. But the solution must have the electric field as the speed of light times the magnetic field. And the speed of light is predicted to be this number. Well, this equation right here, a definite constant velocity, is something that is mind-boggling. This is the foundation of the theory of relativity. How is it possible to have a speed of anything that is always the same, no matter how you move relative to it? Well, it would take approximately 40 years from the time of Maxwell and his prediction through all the measurements of the speed of light that constantly showed it was constant for Einstein 40 years later in 1905 to come up with the theory of relativity that explained that.